Well, the state of the universe is much the same as it was last year. Okay, well, what I wanted to do is talk about what was important in science over the last year or two. You have to remember that our view of science now has changed somewhat. It used to be thought that the view of the universe was all these stars and things. Now the important thing is the fields. There are four forces that go in the universe. They are gravity, and we all know what that is. That holds us down to the earth. Electromagnetism, that's what heats our houses and cooks our food and whatnot. And then there are the two rather different ones. The strong nuclear force that we all know was what gave us the atom bomb, and the weak nuclear force, which is the one that gives us electrons out of our watches and things like that, the beta particles, they call them. Okay, well, today I wanted to talk about the two forces that extend throughout the universe. The nuclear forces are very just the same size as the nucleus itself, which is very tiny. But the gravity and electromagnetism are fields that extend throughout the whole universe. Now, we know a lot about the electromagnetism. It gives us the electron. That was discovered about 100 years ago. No, more than that now. But anyway, J.J. Thomson discovered that. And it's, of course, you get both positive and negative electrons. So some attract, some repel. Gravity, on the other hand, is all attractive. It just pulls everything together. And this, of course, is what is so mysterious about the universe. And of course, we still don't know who created or what created the universe. Why are all these particles here? Whoever it was must have been very keen on math, because in addition to these things I've talked about, you had all the particles that are being produced, and the mathematics that goes with them. It's called symmetry, and we, of course, part of it. We have 2 arms, 2 legs, and so forth. But the symmetry in the universe, you have the eightfold way, and so on and so on. Okay, well, let's go on. What I wanted to talk about was the new telescope for observing gravitational waves. This is gravitational waves and particles. This is the thing that people have great difficulty understanding, that it's both a wave and a particle, as is light. And how can that be? Well, it is. That's all you can say. People have said, whereas the proton, the particle of light, has been known for a long time, nobody had seen the particle for gravity. We knew it was very small. Einstein showed this when he showed that, in fact, the gravity produced particles, and that was well over 100 years ago. But he also showed that these are going to be incredibly tiny, and we probably couldn't see them. And that's proved to be the case. People have tried all kinds of things. There was a guy who used to come by here in Columbia and try and show how he was going to find gravitational waves, but he never did. He had a gigantic lead or some heavy element cylinder, about 3 feet in diameter or more, and he looked for vibrations in that, because gravity waves, as they pass over us, produce vibrations. And of course, if we could see those, that's what we learn about gravity. Well, could we see them? As it turned out, they are much smaller than we thought. And in fact, the actual vibrations are smaller than the proton, the size of the proton, which is a billion of a centimeter or something like that. Very, very tiny. And so Einstein thought we could never see it, and so did everybody else. But people have been trying to do it. And about 2010, the NSF started funding a device for doing that, the so-called LIGO, Laser Interferometer Gravitational Wave Observatory. Nice long name. And that is situated, there are two of them in this country. One is in Louisiana, and the other is in Washington State. Well, why this tremendous separation? Well, the thing is that if you're looking for something which is hidden by the noise, which clearly this would be, if you have it in two places and they both give the same answer, then it's probably real. So they gradually got rid of the noise, passing traffic, waves at the seashore, and so on. And in about 1915, the first, about 2015, anyway, 2015, they found that the first one came in, and they found it at both places. So that was really neat, and it means to say that you can, in fact, see these gravity waves. Well, what are they like? Where do they come from? It turns out that the first ones that they saw were from a collision, an absorption between two black holes. Now, black holes, as you don't know, are stars which are so heavy that nothing can get away. Anything that tries to get out of a black hole is immediately pulled back in at what they like. Anyway, they pull it back in. So if anything falls into a black hole, it never gets out. But Roger Penrose, who got the Nobel Prize this year, worked on that for a long time, and that's why he got the Nobel Prize. He had a student called Hawking. You may have heard about him. He had this unfortunate disease. In fact, he nearly ran into me with his trolley one time because he has a nasty habit of traveling very fast in this thing. Anyway, what happened was after Roger Penrose showed, that nothing can get out of a black hole, Hawking showed that it can leak. It can leak just a little bit. I'm not going to look at that, but the leaks out congeal, and they produce infinitely heavy, infinitely tiny objects that are now called Hawking points. And you can look this up on the web, but these points, of course, he thought, well, we think that these points, as time goes on, what happened? Well, people are always asking, how did the universe start? How did our universe start? And of course, it started with the Big Bang. This is kind of a delightful thing that the explosion, there was a big fight about whether it was the Big Bang or continuous creation of matter that I thought. Anyway, so we go on, and they find that these points can penetrate, if there was a previous universe, they would produce points that objects in our own galaxy. And now you're getting publications which are trying to show that they have seen these objects which date back from a previous universe. If that's the case, of course, we may have a series of universes going on one after another. Well, that's not the case. Who knows? I don't think they're too sure themselves. Okay, so let me show you a picture of this device. So the two arms, instead of being on tabletop size, they find are 4 kilometers. So two arms at right angles And the mirrors at the end are what tell you what's going on. If a gravity wave comes in, it will shake one of the mirrors by the size of the proton, and we hope to see that. In fact, we do see that. And that you can find a lot more about the types of stars and the universe in general, and by these gravity waves. So we started a new discipline. Astronomy started with the telescopes, really. That's when people got to see things. Gravity never got anything like that. Now we know we can see gravity waves. So it's a new discipline beside the old one that extends throughout the whole universe. And hopefully we'll see that. And we find that not only that black holes, but also neutron stars collide. And we can see those, it's a catastrophic thing that produces light as well as gravity waves. And so in the telescopic observations and the ones from the gravity waves agree. So now we're pretty sure that this thing is very real indeed. Well, I think that covers most of the stuff I wanted to talk about. And so I'll hand it on now to my progeny, you might say. How delightful. And that is Lauren and Chris and Michael, or Midge, as he likes to be called. So that's the next step. Here we go.
Hello, everyone. I'd like to bring it back a little closer to home than the discussion of the vast universe we've been hearing before this, and talk a little bit about the developments in understanding and discovering the universe of the mind that were made this year. Hopefully, everyone is familiar with the concept of a pacemaker. So something that can provide electrical stimulation to the heart to restore its proper function if it is misfiring or not pumping properly. Similarly, what you may not know is for certain kinds of diseases, you can provide electrical stimulation to the brain that will restore its proper function. So for example, for particular types of tremor or some types of muscle spasming, if there is something going wrong in the mechanics of the mind, you can provide electrical pulses like a pacemaker for the brain in order to restore proper body function. That's not new this year. That's been around for a while. What is new is up to this point, a lot of that pacemaker for the brain was being delivered without a way to monitor the resulting brain activity. You would just see the relief in the body posture. You would see the relief in the patient, but you wouldn't be able to directly monitor what's going on in this universe of the mind while you're providing this relief therapy. This year, we developed a way to monitor the very noisy, complex place that is the brain, so that while we're both delivering therapy, we can monitor the consequences in the local area of the brain. So hopefully this will be a way to not only learn about this very amazing and complex space, but also to optimize therapies individually per patient. So you can monitor the consequences it's having in this individual patient and really optimize the treatment for that individual. It's a very exciting development, and it happened this year and seemed appropriate for this sermon. In conclusion of what you've heard today, I would like to share one of my favorite cartoons because I think it's appropriate and illuminating. I made it larger for the benefit of the tiny Zoom windows. So I'll just step through those. So I wanted to bring this up because it is one of my favorite cartoons relevant to science. But I think that the philosophy and humor represented in this cartoon is not limited to just an attitude towards science. I think that whatever sphere it might happen in, if that's your personal life or your work life or your hobbies, sometimes even if at the end of the day all you've produced is a very detailed tribute to your wrongness, where you've understood and elucidated all the ways in which you're wrong and why, that's critically important. It's not lost time, it's not wasted effort. Just because you happen to be incorrect doesn't mean there's nothing to learn or that it was wasted. So I wanted to propose this as a moral to our sermon here on this beautiful holiday season and looking into the new year. Thanks, everyone.
Hi, everybody. This is Chris Edge, and I've got a newsflash update for you on the universe from our news reporters who confirmed very happily that the universal constants that we use in physics that you know and love are remaining steady. This includes, for example, the speed of light, gravitational constant, mass of a proton, an electron. You know what I'm talking about. Well, why should you care? It turns out that we should care very much because all of these constants are finely tuned and balanced one against the other. And if any of them were to vary a few percent, we wouldn't have the universe that we know. So for example, if the gravitational constant was just a bit too strong by a few percent more than it currently is, then after the Big Bang, instead of the nice galaxies and stars we have, we would have wound up with a black hole. It all would have collapsed back down again. Or on the other hand, if the gravitational constant had been too weak, then the universe just would have kept on going and expanding. It wouldn't have been coalescing into galaxies and stars and so forth. Or if they did coalesce, you would end up with big red giant stars, which are not at all very hospitable for life. Likewise, we would have had no carbon from the supernovas, and therefore there wouldn't have been life as we know it. So why is this good news? It's good news because the odds of all this happening, according to Penrose and the other physicists that Dad knows and loves, claim that it would be virtually impossible for this to happen by accident. And clearly, therefore, there is a creator who intends for each one of us to exist. So with that good news, I wish you Merry Christmas.
Hello, everyone. Mike Edge here. I'm here to talk about the Ig Nobel Prize, not as well known as its more famous cousin, the Nobel Prize, but it celebrates that science is not always predictable, it is not always dry, it is often interesting. So the nice thing about the Ig Nobel Prize is it comes with a $10 trillion reward. Unfortunately, those are Zimbabwe dollars, which due to hyperinflation are worth about the price of a loaf of bread in 2009. But still, it's an august body, it's an august award, and people attend and they are excited to get that award. Now, in years past, there have been such interesting research as showing that when humans go to the zoo, that the chimpanzees imitate the humans about as often and about as well as people imitate the chimpanzees at the zoo. And then there was another case where a researcher showed that pizza can help fight cancer as long as the pizza is made and eaten in Italy. So science, research. But 2020 was a little different, as in so many cases. And this year, one of the great awards went for some researchers who showed that knives made from human feces do not work. Now, the story behind this is there actually had been a story about an Inuit man who, showing great resolve, had made a knife out of feces and managed to survive. And this story had been accepted as true for over a decade. These scientists bravely made knives from their own feces and tested it and found it wasn't right. And what's interesting about this is it really is science. Science means questioning, science means testing, and not blindly accepting. And in this particular case, for over a decade, this anecdote had been repeated as if it were true, and no one had thought to test it. So the Ig Nobel Prizes glorify and celebrate that science is often wacky, but it's all about questioning and testing. So I highly recommend going to improbable.com and learning more about the Ig Nobel Prize. But science is real, and science is often unusual. At any rate, this is Mike Edge, hoping I have made science a little bit more accessible. Take care.